Okay, we're going over graphing linear relations using a table of values. Okay, so as you notice, we have a table of values here, and they've given us a graph. That's great. Our equation is x plus y is equal to 6. Remember I told you using a table of values we're grabbing arbitrary numbers, right? Again, what I mean by that, we need numbers between, essentially, we usually try to find numbers for x first of all, but you can do y, it's completely up to you, and just do it vice versa. But we have negative 10 and positive 10. So if I really want, I can choose negative 10, negative 6, negative 1, 6, and 8. Those are all arbitrary, they all fall in here. And they'll give me an idea, especially because this is a straight line, where it's going to be. But it's usually best practice to choose numbers that go up on a certain pattern. So for instance, in the other question I had gone up by negative 2, negative 1, 0, 1, 2. I went up by 1. Or maybe I'd go negative 6, negative 4, negative 2, 0, 2, 4. Always moving by 2. It's best practice to go in a pattern increment. So up by 1, up by 2, up by 5, something like that. Okay, instead of just choosing any random ones. In this case, let's maybe try to go by 3. Okay, negative 9. I'm going to go up by 3. So we're going to have negative 9, negative 6, negative 3, 0, and 3. Okay, all of those fall between negative 10 and 10. I've chosen these numbers for a reason because I want to show you what happens when you get a number that might not be on the graph. Okay, so the very first one I take is the number negative 9, and I'm going to plug it in for x because I have that under my x column. Okay. So when x is equal to negative 9, we get negative 9 plus y equals 6. When I move 9 to the other side, what do I get?
6 plus 9.
6 plus 9, which is 15. Does 15 fall on this graph? No. That didn't work for me. Okay? It doesn't mean it's wrong. As long as I've done the math right, I probably do have a point on this. But remember, lines go on forever, so this graph just wasn't big enough to encompass it. So let's try another one. Negative 6. Okay? Negative 6 plus y equals 6. What's y going to equal? 6 plus 6, which is... Does that fall on this graph? No. But are they getting closer? That's very important. Okay? If I start off of the graph, okay, like we did, 15, and then I happen to go maybe to 18, that might mean, 18, that might mean I'm going in the wrong direction. If I keep going that way, I'm going to just keep getting numbers that are off the graph, and I should switch my direction. And what I mean by that is we were going in a positive direction with the x's. If this happened to be 18, I might need a number lower than 9 to get onto this graph. Okay? That's the idea of choosing arbitrary numbers. So we're getting closer, so let's continue with that pattern. Negative 3 is our next one. Negative 3 plus y equals 6. I move 3 to the other side, what do we get? 6 plus 3, which is good. Does that fall on the graph? Yes, very helpful. Okay, so now I have a coordinate. X is 3, y is 9. That's going to be on the graph. So we go to negative 3 and 9. Here's one of our points. Let's try 0 now. 0 plus y equals 6. What's y equal?
6.
Nice and easy. So when x is 0, y is 6. And then finally, what's the last one we did? 3? 3 plus y equals 6. Y equals 6 minus 3. Y is 3. So, at 3, y is 3. These all fall on this line. Okay? And this line probably continues in this type of pattern. So there's our line. I only technically need 2 points. I wanted to fill out my graph, though, just to make sure that we had everything correct. So this was at 6 and 3. So that would be the answers to the first one on your page. Okay? You could have chosen different numbers, but your graph needs to look like that. That's what your line should look like.